Hello, everybody, and welcome to our now third episode of Keep Talking with Noah and Timwi. I'm going to be our host for today, Noah, and this is my co-host, Timwi.
Hello, everybody. All right, our topic today is the ethics of space exploration and alien first contact. At least that's how I wrote it on the screen. We'll see how the conversation develops. Have you already thought about this topic at all, Noah?
Vaguely, we conversed about it a while ago when you introduced me to the concept that this might be, a bad thing, like this, contaminating an alien planet, sort of like the old world, new world thing. So I'd vaguely thought about that, but not in any depth.
So have you heard about um have you heard about okay, you know about the space agencies, NASA in America and ESA in Europe? They have these extremely strict protocols, on what they do with spacecraft and equipment that will go anywhere near a planet or even land there, right? Things that are intended to land on Mars have to be incredibly sterilized. And they already have a policy in place for when or if they're ever going to land anywhere near a body of water or any other liquid in which a biological material could cause a reaction or could cause, right. The idea here, of course, in fact, there are several concerns here. The main concern is that if we later land on a planet or moon or whatever, and then we find microbial life somewhere in its oceans or its ponds, whatever, we really don't want that to be something that came from Earth on a spacecraft we had sent earlier. Right? I mean, it would make a huge splash if we found microbial life, and then we would have to retract it and say, oh no, actually, those are just bacteria that we accidentally contaminated that planet with. Right?
Is that, honestly, I feel like it'd be still an amazing achievement to have, bacteria and life brought from Earth to another planet still. Like, I understand it's not as exciting, but it's still kind of crazy.
So when you say crazy, do you mean the thought of seeding another planet with life from Earth?
Yeah.
Okay, well, if you were to plan for that deliberately, then that might be an interesting enterprise. But what they're trying to avoid is to do it accidentally.
Mm-hmm.
If you're at least planning to do it, then yeah, but they're not planning to do it. They're sending probes to the planets in order to study the planets as they are, and not to change the planets.
Fair enough.
Right. Have you heard of what is sometimes called the Fermi paradox?
No.
No.
Not at
Interesting.
all.
So have you heard of the physicist Enrico Fermi, after whom it is named?
Nope.
So Fermi, at some point, at some kind of gathering, I don't know the details. I'm guessing it was a sort of physicists gathering, right? They were having dinner, and Fermi famously got up at some point and asked the question, where is everybody? Right? I mean, the table was full of people, right? It's not that he was waiting for guests or anything. Most of the people on the table knew what he meant, because the conversation had already been about space, about the vastness of space, about the incredibly huge number of planets and moons and solar systems and stars that we can see. We've already cataloged millions of them. And we've seen billions that we haven't cataloged yet. So we know that the universe is full of opportunities for life to arise. And yet, where is everybody? We have not actually received any sort of evidence of life actually existing anywhere. Okay? So that's the paradox. Why have we not seen any evidence of any form of life, despite the fact that the universe is so vast that there should have been ample opportunity for life to arise in many places?
This leads into something that I know we talked about earlier, so maybe we talked about this earlier as well. But I think it's called the Great Barrier.
The Great Filter.
The Great Filter, yes.
We will get to that.
Okay, I imagine those go hand in hand.
Indeed. So the Fermi paradox is a paradox because on the one hand, you think that life should be abundant in the universe, but our observations suggest that it isn't. So several hypotheses have been proposed to explain that, and many of these hypotheses are on the basis of physics or physical phenomena or whatever. So I'll run down through those quickly. But some of them are more philosophical in nature, and I want to go into more details on those with you and see what you think.
Sure.
Okay, so one hypothesis, which is mostly in terms of, science, is that life itself may be rare. It may be that for life to evolve, for anything like life as we know it to evolve, you would have to have incredibly specific circumstances which can only coincide under very rare circumstances. We know that life on Earth started with a chemical reaction that involved some amino acids somewhere swimming in a pool, which needed to come together under the right circumstances, the right temperature, pressure, and the right ingredients in the right concentrations to form what we call a self-replicating molecule. In other words, something that can copy itself, that can sometimes modify itself, and thus you have something that natural selection can work on. Right. So this is called abiogenesis. This is the beginning of life from non-living matter. We don't know much about exactly how it happened on Earth, but the only ways that we know that it could have happened require extremely lucky circumstances. So it's possible that these circumstances are in fact so lucky and so rare in the universe, that it just doesn't happen on other planets. Or at least not on planets that are anywhere near enough for us to detect it. So that's one. And then the next one is that even if you do have that rare circumstance that kickstarts life, it doesn't necessarily follow that life must evolve into intelligent life. Because there is another great a coincidence that happened in the evolution of life on this planet, which is multicellular life. Life started out single-celled, and if you think about it, for a single-celled organism to turn into a multi-celled organism, something extraordinary must happen. The cells must somehow specialize, they must collaborate. Instead of competing for all the resources, they must find some grounds on which to be mutually beneficial to each other. Right? So it may be that is also something that is extremely rare. Then the next one is that even if you have an intelligent civilization, it still doesn't follow that civilization necessarily develops technology. It is possible that there is something special about a particular brand of intelligence and, curiosity, creativity, whatever, that makes it possible for us to send radio signals or to receive radio signals, to encode and decode messages and stuff like that. Maybe this is just not on the forefront of the technological development for most other forms of intelligent life.
The idea that I'm sort of getting from this is that it's a numbers game. On the one hand, there are, practically infinite places in the universe, right? The universe is practically infinitely large, so it follows that there would have to be life somewhere. But also, the ability for life to both form and then also survive and not just get killed out in one stage or another is a practically infinitely small chance, where we are the only example we know of it.
Exactly. This is sometimes referred to as the cosmic lottery. It may be that we are the only winners of the cosmic lottery. But anyway, so the ones that I've listed so far are all coincidences that are necessary for life to evolve in the first place. To each of these, Fermi might rightfully say, well, even if these events are rare, there are so many planets and so many places that they can happen that, there's bound to be somewhere. So, the next one on this list that I have here is that maybe intelligence itself is inherently unstable in the form of a civilization. In other words, it may be in the nature of intelligent life to destroy itself. And we've already seen some near misses in the history of humanity, right? Some some crises come to mind. The most notable probably being the Cuban Missile Crisis. Historians looking back at that might easily say that was the point at which we could easily have destroyed ourselves through a nuclear war, followed by a nuclear winter, followed by an extinction event.
Yeah.
And we just lucked out, and we didn't. We survived.
By the skin of our teeth, it seems. I find that an interesting idea, right? That life is sort of inherently, or intelligent life is sort of inherently self-destructive in nature. But there's an important note that, like, just because intelligent life, and specifically this is, of course, play the numbers game a bit more, intelligent life that has the ability to create technology may develop the ability to become inherently self-destructive, but that also does not speak for the unintelligent life, of course, that intelligent life had to develop out of. And the also something that I just thought of is the unnaturally long span of time that it took life to get this intelligent here. Or I guess by unnaturally I meant completely naturally, because of course it's nature.
So are you referring to the entire time span since the beginning of life on the planet?
Yes.
Right. That plays into what I said earlier, that maybe intelligent life just usually doesn't arise. Because on this planet it took, 4 billion years for that to happen? So it's entirely possible that it's a huge coincidence that it happened at all. Because once it happened, then suddenly technological progress just exploded exponentially. The first moment that we were able to send signals into outer space was 1937. That was when the first radio telescope or radio antenna went into operation. And that's less than 100 years ago. Compare that to 100,000 years that humans themselves have existed, and compare that to hundreds of millions of years that multicellular life has existed.
That was interesting, though. It made me think of something. Do you think it's a coincidence that we are the only form of highly intelligent life on this planet? Do you think multiple forms of intelligent life can coexist together? Or do you think that they were and this is just a coincidence that we just happen to be the only intelligent life that formed? Or do you think that other budding, flavors of intelligent life were destroyed in this sort of carrying capacity per biome, per planet of one intelligent life form that sort of overtakes the others?
The way that you phrased that sounds like you're specifically asking me on my opinion. I'm a bit thin on the scientific facts here, but what we do know is that humans, Homo sapiens, isn't the first species that invented tools. So, Neanderthals and Homo erectus and not quite sure about Homo floresiensis. I think they may have also employed tools. Each of these were separate species from humans, from Homo sapiens, that is. I mean, it's difficult because if you look at a Neanderthal, if a living, breathing Neanderthal stood in front of you, you wouldn't immediately say that's not a human. It might look like a slightly deformed human, so you might assume that's probably a human,
with a defect or something.
Yes, and you wouldn't immediately jump to the conclusion that the defect must also impair their intelligence or their mental capacity or whatever. Anyway, so it is a fact that humans aren't the only intelligent species that has arisen, but we are the only intelligent species alive now. All of the ones that I've listed, like Homo erectus, they all became extinct at some point. And it turns out we know surprisingly little about why. We don't know if Neanderthals just became extinct because of competing resources, competing with humans on resources. We don't know if they became extinct for some entirely separate reason without humans doing. But it could also be that humans and Neanderthals actually fought a war of sorts at some point. That's entirely possible. We really genuinely don't know.
That's unfortunate.
We don't even know the exact level to which Neanderthals were able to communicate via language. Right? We don't know if language was unique to humans. But what we do know is that their vocal cords were, different to a point where, their languages would have had to be different. But that doesn't mean that they would have had to be lower in complexity. If that makes sense.
No, yeah, I get it. I it always kills me to think about this because it's so much, what could have been. It would be so interesting to have multiple species of intelligent life on the same planet, and I'm curious if that is possible.
A slightly related question is, what about the emergence of life itself? I mean, what I said is that we had this coincidence where, the right amino acids formed together into the first self-replicating molecule and stuff. We don't actually know how often that happened on the Earth, but we do know that every single living thing alive today, including plants, fungi, and bacteria and everything, all has a common ancestor. So we don't know if there are more than one origins of life, but if there were, then all the others have gone extinct.
That's really interesting. When hearing about alien life, I often hear it discussed that it's not necessary. It's bad to assume that life even functions or is formed even anywhere similar to the way that it is on Earth. So it's interesting to think about that could have developed here on Earth as well, just didn't make the cut.
That ties into another thing that's on my list of possible answers to the Fermi paradox.
Mm-hmm.
I'm sorry for hijacking your point there, but one of the possible responses is that maybe alien life does actually exist, and the evidence would be there if only we knew how to look for it. But we don't because they are too alien, and we just don't understand their nature.
Oh, so we're looking for evidence of life as we know it, but they may be leaving evidence of something that we wouldn't even recognize as life.
So one example that they give is that if you had an intelligent species whose thought processes are orders of magnitude faster or slower than ours, then their communication would very easily be mistaken by us as background noise. If you take a human radio signal and just speed it up by a factor of 100, it's unintelligible. I mean, if you knew that it was a radio signal that was sped up 100 times, then yeah, you could slow it back down and then hear the message. But if you just heard the sped up variant and you don't know what it is and you had to filter it out from all sorts of background noise that you get from the cosmos that you already know is from natural causes, you would easily mistake that for a natural signal as well.
Mm-hmm.
And the same if it's slower, if you slow it down by a factor of 100, then you might not even recognize it as a single signal. You might recognize it only as individual bits and pieces which you pick up separately.
You wouldn't be able to tell it was all one message. You would assume that it were several messages. The same way, if you slowed something down, you might pick out words, slow down a speech by 100 times. You might pick out a word and think that it's several things that are being said because it's so long.
Yes. On top of that, of course, if you had a civilization that does have these really slow thought processes, then even if we manage to send them a message and they manage to receive it, it might then take them hundreds of years to respond. Because to them, 100 years would be what is 1 year to us. Because if we received an alien message and we had the intention to respond, we would certainly deliberate about it in the international community at large. So it would probably take on the order of a year or maybe a few years to agree on a response. But such a slow-thinking alien civilization would easily take 100 or 1,000 years.
Do you think it would take us that long to come up with something to say? Especially because there are definitely going to be people who are going to try and break the system and send a message without
consensus.
Mm-hmm.
Well, that's interesting. I think that also came up somewhere in this list. Maybe we'll get to it. but in order to send a response, you need to have access to the equipment,
Mm-hmm.
right? Which already limits the potential number of people who could, do a vigilante job like that to very few, right? But then even if one of those were to do it, what do they gain from sending a response? And
You're not wrong. I see exactly where you're coming from, but I feel like they gain notoriety, which is already massive. It's a massive incentive when it's something this noteworthy.
and besides, even if someone were to do that, we can still deliberate on another response to send after,
Of course.
which does have international consensus. So the process would probably still continue. Right, moving on in the list, there is another possibility, which is that intelligent life might inherently have a tendency to destroy others. Now, this need not necessarily mean that, every intelligent life is malicious or predatory, but if you consider all the historical events in the history of humankind, where, a civilization meets with some other civilization on the other side of an ocean, in almost all cases, the results were usually disastrous for one of the two.
Mm.
That applies to Native Americans, that applies to Australian Aborigines. A lot of these cultures have been decimated, and it's not just the introduction of diseases. I mean, that was, of course, a huge factor on the American continent, but
Was it not on Australia?
I don't know. That's an interesting question that we could research at some point. But the real point is that one of the two cultures will have a more sort of aggressive culture, I guess. Not aggressive in the sense of imperial, but their culture will just simply absorb the other culture, and then you're left with with one culture.
There's an interesting idea that I talk about quite a bit, actually. I don't know if you and I have had this discussion, but it's the idea, and usually I use this on a more personal level, but it comes from the higher level of cultural dominance. It's the idea that some people and some cultures, some thinking, some thought groups are more culturally dominant than others, where they've got this way of being. A really good example of a culturally dominant culture in Earth's history was, I think, early Ottoman Turkey, where they were very good at adapting other people into their sort of style of life and existence. And they sort of, as opposed to, it's like to be sort of culturally dominant, there's this mixture of accepting but promoting the things that keep the culture the same, so it never loses what it is. It just allows people who are not originally part of it to take part of it in such a way that it's the easiest meshing of these two cultures is for the culturally dominant one to remain the one on top.
I don't know anything about Ottoman Turkey, so I can't respond to the specific example, but I'm surprised that you didn't mention the United States as it is today, because a lot of people living outside of the United States would consider the United States to be culturally dominant. Quite a lot of ideas and cultural items, like music and movies, all seems to come out of the United States.
I don't consider the United States a good example, because the United States isn't doing this because it's necessarily a strong culture. It's doing this because it lucked into having access to a lot of these technologies and a lot of money to spend into the humanities at a time when the countries in Europe were going to war, and other countries were just getting or just developing this technology.
But we're not at war anymore now.
No, but the United States sort of solidified itself, and even now, other countries that are now gaining this and are now in times of peace are taking back influence as well. The United States just got a huge advantage early. I don't consider that to be the same thing as what I'm talking about with cultural dominance.
Okay.
I'm talking about when the culture lends itself to be sort of all-encompassing while still promoting its own ideas. Promoting its own ideas while also... a great example is the sort of early initial spread of Christianity pre-Roman Church, but like the grassroots spread of Christianity through the Roman kingdom. it was a very all-encompassing, easy ideals thing to just follow. And it was, despite being all-encompassing and, easy for cultures to mesh with it, it always kept itself on top. It was good at protecting its ideals while also meshing with people who didn't necessarily like them.
But it didn't really keep itself on top of the Roman Empire until around 300 or so, when the Roman Empire adopted Christianity as its state religion.
So the idea, and maybe I know a wrong version of the story, but I thought the idea was that it was already spreading throughout the public, and the Romans adopted it as the state religion in order to control it rather than out of any other reason. Right, it was already spreading, and they adopted it in order to take control of the church and profit off of it, rather than to allow it to spread in the grassroots fashion it had already been doing, like a virus through Rome.
That sounds interesting. I'm definitely gonna take a look at that. All I know about it is that it existed alongside Roman and Greek religion for hundreds of years until that fateful time in the the 4th century, in which a Roman emperor whose name I've forgotten adopted it as the state religion, which incidentally is also the time when the Roman Empire eventually conquered the Greek peninsula and the Greek civilization, and that's also the time when the Greek Olympic Games, the ancient Olympic Games, which were, a ritualistic, religious ceremony for the worship of Zeus, was banned, and that's when the Olympic Games ceased until they were revived in 1896.
That's extremely interesting. I didn't know that about the Olympics.
Oh,
So
I definitely have a long story about this, because when I read about this, about the demise of the Olympic Games, that is one of the few real life historical events that had me in tears. Because I read this account on how the Greek culture, the Greek city-states, etc., they were all at war with each other. They distrusted each other. And it was extremely unsafe for anyone to leave the boundaries of their particular city wall. And these city-states, they would include Athens and Sparta and Troy and whatever else. But then every 4 years there was this event, the Olympic Games, which provided a safe haven and which provided a break in the hostilities, right? And it sort of evolved into this for most of the 4 years, the span of 4 years called an Olympiad. For most of those 4 years, each of the Greek city-states would think of themselves as their own thing. We are Spartans, we are Troys, we are Athenians. And just for that one span of a few days, they would all come together and say, we're all Greeks. We are one, we're united. And that's just beautiful. And, they would come together and celebrate their commonalities rather than the differences. They would celebrate their worship of Zeus. They would celebrate their fascination for the human form, which is why sports events and stuff like that. And they had all these unwritten rules, about not just the athletes but even the spectators were granted or were guaranteed safe travel to the Olympic Games, because in theory anyone could just sneak up on them and just kill them in order to secure their first place in the Olympic Games. But in practice that never happened, because the political and social repercussions of that would have been enormous, and they really didn't want to spoil that experience of togetherness that happened only once every 4 years.
It's funny. It reminds me vaguely of Eurovision.
Interesting. Did not see the parallel there. But yeah, so you can imagine how angry I was at Christianity when I read that this all came to a stop because the Roman Empire adopted. Because the Olympic Games in Greece were allowed to continue even after Roman occupation, but it was the institution of Christianity as the state religion that put an end to it.
That's interesting. So, this is we're pretty deep in tangent territory here. So I don't know if we want to continue on this path. But there's a lot of things about and I briefly mentioned that my father's studied theology, so this is something that's talked about a lot. This idea of the pre-Roman Christianity and what it was like, and what Romanization, that the Romanization of Christianity was much more a change to Christianity to suit Rome rather than an implementation of, right, rather than Rome adopting the Christianity that existed, if that makes sense.
It does make sense, but I don't know anything about it.
Yes, that's fair. But anyway, cultural, to sort of trace back to the point, cultural dominance, because of that, multiple intelligent life forms on a planet, I think, or do you think it would be one would necessarily subvert the others?
Unfortunately, yes, I do think. I do think that is necessarily going to happen, because if these two species are indeed separate species, they're not going to have the exact same level of intelligence. One of them is going to have some kind of advantage, and that advantage is just going to compound. So I don't think that a stable situation could arise in which, one of the two. In fact, if you think about, what do we even mean by intelligence? We keep saying, oh, humanity is the only intelligent species on this planet. But, dogs have some form of intelligence. Dolphins have some form of intelligence. There are a lot of species on this planet that have some level of intelligence, and humans just happen to have, the most of it.
So this is something that when you were talking about, I sort of picked up on this. So there are like these two tiers of intelligent life that you divided pretty quickly with. Some intelligent life is capable of developing technology, while some is not. So I considered like there to be tier 1 intelligent life, which is literally anything with a brain that has that has the ability to use it. So for instance, most animals on this planet. And then tier 2 intelligent life is animals that can use tools outside of their body to accomplish goals.
Okay, so that would still include some animals. Many great apes, for example, chimpanzees and gorillas, as well as some bird species, most notably the corvids, ravens and crows, have been known to employ tools to achieve certain tasks in the wild, not just in human experimentation.
Mm-hmm.
Chimpanzees go a small level further because they've succeeded in certain cognitive tasks that humans have thrown at them, which actually, quite baffles us, that they are able to solve some of those sort of, things that involve certain shapes, colors, numbers, logical relations and stuff,
Mm-hmm.
and yet they're not able, to put that intelligence to some kind of practical use. But, obviously every time someone comes up with such an experiment and the chimpanzees just sort of excel at it, randomly, that makes the news. But all of the experiments where they just completely make a fool of themselves, or should I say, just monkey around, don't make the news, right? So, probably shouldn't put too much weight on that.
It's interesting, even that you brought up as well, the
corvids.
So here's something interesting. Those are what I consider to be like, in between the stage 1 and stage 2 that you described, which humans, and I assume we're also in that stage, 1.5 as well. Do you think that humans being the dominant intelligent life means that evolutionarily handicaps other species from growing intelligent, to challenge, to rival us as the dominant intelligent species?
Okay, I need to answer two questions here before I can answer yours.
Okay.
First of all, I'm a bit confused that you said that even humans are only tier 1.5, you said?
At some point, humans had to be tier 1.5.
Oh, I see, but you define them as tier 2 now?
I confused myself and used different nomenclature in the middle of my point. I define humans as being at the top of tier 2, where they've sort of mastered the use of technology, where I consider then these corvids and great apes to be in this tier 1.5 to early tier 2 stage.
Well, since you've now introduced the concept of having a tier 1.5, it sounds like it's a sliding scale rather than a specific sort of bucket or pigeonhole. If it were,
Yes.
if it were a pigeonhole, then I would ask you, where is the dividing line between tier 1 and tier 2? But anyway, so the second thing that I needed to ask is, how exactly do you define surpass, or whatever it was that you said? Because if you imagine for a moment that the most intelligent other species on this planet, like let's say chimpanzees, were to experience some kind of genetic mutation that would make them about as intelligent as humans, what would we do if that happened? And what would they do? What would, the newborn chimpanzees who are suddenly far more intelligent than the chimpanzees around them? What would happen? I think it's pretty easy to see that we wouldn't let that strain of chimpanzees just grow into competitors to humans, right?
Do you see? I would say that I probably imagine if this was happening, there'd be a large effort to sort of allow these to, this new strain of chimpanzees to grow uninterrupted by humans and try and, see if we can develop intelligent life a second time.
Okay, but I suppose it also makes a difference as to whether that new strain has arisen in the wild or in captivity. In fact, the mere fact that we can keep chimpanzees in captivity, is a consequence of the fact that we have this greater intelligence, right?
I do not agree with this. Humans have been kept in captivity by other humans.
By other humans, yes. But what I'm saying is that humans have never been kept in captivity by a species of lower intelligence.
Okay.
Right? Similarly, if an alien civilization were to come along that is clearly far more advanced in terms of their biological intelligence, they could very easily put us into captivity, and there's nothing we can do about it.
Do you think we'd recognize if we were in captivity?
Well, that takes us back to the Fermi paradox, because that's another one of the points on the list. But to come back to your question then, if some species like chimpanzees were to develop a level of intelligence that could rival humans, my personal prediction is that we would probably stamp it out. I mean, not quite as explicitly, we wouldn't like declare war on them and, declare the intention to wipe them out, but we would fail to stop ourselves from doing things that would have that effect. Can you imagine a chimpanzee enrolling in a university course?
Wow, we just took a huge jump.
Yeah, no, but I mean, if such a chimpanzee were to be born at some point, right? And if it became obvious by the chimpanzee's adolescence that it learns at approximately the same pace as an average human, then the question will arise: will we allow that chimpanzee to enroll in a university? Will we allow that chimpanzee to adopt a job and to earn money and to own property, which, by the way, is another thing that distinguishes us from animals? We can take their property away and there's nothing they can do. It is up to us to define their rights.
See, now, this thing of, would we allow a chimpanzee to participate in our society, I think is immediately a no. But I don't think it's a no because, I think it's a no because the idea is that you want this chimpanzee in the chimpanzee society so that you can attempt to allow it to further that.
Yeah, you could argue with different intentions, but the effect is the same. The effect is still that we're going to be excluding that chimpanzee from human civilization, and therefore deny them the opportunity to catch up with human, cultural and technological advancement.
Well, I guess the idea isn't necessarily to catch up. The process, I guess I'm trying to talk about the process of starting developing intelligent life as with humans was, like, from scratch. we wouldn't fast track them back to where we are, but I would imagine we would allow them to develop the same way we did.
But they're not on the same planet that we were. They're now on a planet that is inhabited by humans. By humans with an advanced technology.
I figure, though, we would attempt to make it as similar as we could to them. Like, we would attempt to relegate them to places on the planet that are similar conditioned-wise.
Notice that you said we would relegate them. That is what I mean. We are the ones that are still in control. We are the ones that decide their fate.
Do you think they could ever develop to the point where we would no longer feel comfortable doing that?
Oh, I'm sure that a lot of activist groups would say straight away that they're not comfortable with that. That, a lot of animal rights activists would say to keep that being in captivity is unethical. And even to release them into the jungle, which is supposed to be the natural habitat of their species, could also be seen by many of them as unethical, because we know that life in the jungle is rough. Life in the jungle was rough for us before we had technology, before we knew how to build houses, before we knew how to build weapons to defend ourselves against predators. Life was rough, right? And to send even a human back into that kind of quote-unquote natural habitat would probably be seen as quite unethical. So why would it be any different for the chimpanzee?
That's a good point. With that argument in mind, I think it makes sense to keep them in wherever they were that it developed, even if that is in captivity.
Right. Well, if it's in captivity, then that puts a lot of burden of decision making on us. We would have to decide, whether or not to educate the chimpanzee child, whether or not, or what information to educate them with, what to tell them regards to their place in the world. Should we raise them to believe that humans are their overlords? Should we raise them to believe that, we are equals and they should stand up for their rights? These are all very, very difficult questions.
Can I...
Go ahead.
Can I do something interesting here? Now, what would we want if an alien species were to discover one of us and ask themselves those same questions?
Aha. Well, I would love to answer that, but I would first like to get to the zoo hypothesis, which is one of the possible answers to the Fermi paradox.
Sure.
If you don't mind. So, do you mind if I continue the list in the order I have it here, so that I know which parts we've already been through? Because in the category of physical events that can happen, there's another one that I wanted to mention, which is that the universe itself is pretty hostile to life, and if you look at the geological record on Earth, there have been a lot of extinction events in the past, right? Meteors keep slamming into planets, and all sorts of catastrophes happen. Volcanic eruptions, supernovae, gamma ray bursts. Maybe all of these massively destructive events are too common for life to evolve to the point where it can develop technology. And once again, we just lucked out.
This still doesn't explain why we can't find life by ourselves, just searching for it. Well, it explains why we can't find intelligent life, but not life in general.
Oh, true. Well, life that isn't intelligent probably doesn't send out radio signals. So,
oh, well, yes.
So the answer to that is easy. We just haven't been able to look anywhere outside of our solar system because we don't have the technology to leave our solar system yet. The only evidence that we have, that we could possibly have of alien life, is in the form of radio communication or any other kind of long distance kind of message encoding. So it would necessarily have to be intelligent life.
Then, out of curiosity, let's put the predictions down now. In the eventual age that humanity will be able to send probes outside of our solar system and scour the universe for life, do you think life will be more common than we think? Or do you think life will be common, like unintelligent life will be common, or do you think it will be still as rare as intelligent life has been?
My response to that is simple. I don't know. in our last episode, we talked about Bayesian reasoning, which is a way to
Mhm.
assign probabilities to hypotheses given incomplete data, right? And so my intuition right here tells me that my data is so incomplete that any hypothesis, whether unintelligent life is common or uncommon, is equally likely and is equally surprising.
That's fair. I don't know. It seems like even if it were common, you'd think we'd be able to see it because we can see planets outside of our universe, solar system.
Actually, I know what you mean, but we don't really know much about those planets. We can usually only infer their existence indirectly through, optical effects of gravity or of the fact that they orbit a star and stuff. We haven't actually seen a planet outside of our solar system directly.
Really?
Yes, really. If you were to point a telescope at such a planet, its appearance, its light, its image would be absolutely drowned out by the light of the star that it's orbiting.
That
So,
makes sense.
so all we know about planets outside the solar system comes from observing the exact motion of the star, because it might wobble left and right if a very massive planet orbits it. It comes from absorption spectrums. Like if a planet passes in front of a star, then not only does the brightness of the star dip, which tells us that there's something that moves in front of it, but we can look at how much it dips at every specific frequency of light, which tells us quite a lot about the composition of the planet's atmosphere. If the atmosphere is very rich in, like, let's say hydrogen, for example, then the spectral absorption lines for hydrogen would become very visible. Right? But even this requires extremely careful analysis of it requires very advanced technology to be able to capture images precisely enough and to perform these kinds of analyses to make those kinds of deductions about those planets. But every picture that you ever see of an extrasolar planet is an artist's rendition. We have not actually photographed one yet.
That's really interesting.
By the way, just as a little anecdote, which the first time that this ever happened, the first time that we found proof of the existence of any exoplanet at all, was, I think, in 1995. It might be plus or minus 5 years, I don't know, but let's just say it was in 1995, in which case I would have been 14 years of age at the time. And I remember asking, random adults in my life, how many planets in total do you think we know of? Right? And obviously most people don't know about astronomy, so they assume, we have lots of telescopes, we see lots of stars, so they just say millions or billions or maybe even just thousands, right? And they were all surprised when I said that the answer is 10, because we know of 9 planets in our solar system plus 1 outside. Right?
That's really funny.
But it's staggering to look back at that and to realize just how many exoplanets we know of now. Because now the answer really is in the hundreds of thousands. Not hundreds of thousands. I think it's somewhere between 100 and 1,000. But I don't know exactly. So ever since that first discovery in 1995, we've made tremendous progress in all of these technologies that can deduce the existence of exoplanets, but we still haven't actually seen one. So, the next item on the list is that intelligent civilizations might simply be too far apart in space or time. We all know about the general theory of relativity, which prevents anything, literally anything, not just light, but any kind of information or influence to travel any faster than the quote-unquote speed of light, which should really be called the speed of causality. Right? So,
Yes.
So if an intelligent civilization were to occur like 1,000 light years from here, then any message to be sent back and forth necessarily must take at least 2,000 years. So back and forth communication is just going to be really hard.
I can, especially for us. So that's interesting then. Knowing that then, do you think if we were one of the if if we were hypothetically one of the slower thinking, aliens that you were bringing up earlier, do you think we would be more likely to make contact with people?
Well, to say that we're one of the slow thinking ones is just the same as saying that they are faster thinking than us, because it's all going to be relative.
So the idea is then I'm saying that.
Yeah.
Do you think we're on the much faster end of that spectrum?
I don't know.
Rather, do you think relative to simply the speed of causality, we are fast? And if we were slower, then there's more of a chance that we would be able to communicate because the time barrier would be less important.
Interesting. I hadn't really considered it that way, because the speed of light already has, somewhat of an effect on the design of microchips in computers today. These circuits are just getting smaller and smaller, to the point where the speed of propagation of signals in the circuit prevents us from making the electronics run faster. So the same may very well be true of any sort of, intelligence that has evolved. But it's really hard to because we don't work on the principle of electrical circuits. The thinking processes in our brain work on the basis of chemical diffusion, which in comparison to electronics is already glacial. So the speed of light, literally makes it just isn't a factor in the equation for us, for our thinking speed.
Rather, I'm talking about an alien race that would think slower than us. The time that, the 2,000 years time that it would take to send signals back and forth, that time would not be nearly as long to wait for them because they think slower. So from their perspective, it feels like time would be moving faster for them.
That's possible, yeah. One thing that the article on the Fermi paradox here leaves out is that the speed of thinking process is not necessarily the same as lifespan. You can easily imagine a species whose thinking process is much faster than us, but still lives only about the same amount of time as we do, or even much less.
Oh yeah.
I don't even know which would be more likely. If you did have a species with a much faster thinking process, it stands to reason they also have a higher metabolic rate. And if they have a higher metabolic rate, it also stands to reason that they have a shorter lifespan.
Yes. So hence also why having a slower thinking speed would be more beneficial in the search for extraterrestrial life.
Right. Which takes me back to the idea that an alien civilization might easily just be too alien for us to notice, because even if we were landing on a planet that is inhabited by slow-thinking aliens, we might just mistake them for rocks.
Yeah.
It sounds comical, but it's scarily plausible that we might land there and we see all these formations and we think they're just, an interesting geology. And from the aliens' perspective, some sudden blimp just happened. Something fell from the sky and then somehow bounced off the floor and jumped back into space somehow, and they might easily mistake that for a freak event of nature rather than an intelligent encounter.
I imagine landing on any exoplanet, the people would take this into account and try and figure this out.
Oh, sure, but they would figure it out to the extent that they can as humans. But that again takes me back to the point that since we're the only intelligent civilization that we know of, we have no idea just how alien aliens are going to be.
Here's a question. Imagine there's a hypothetical. We land on a planet with all of these slow-thinking aliens, and we immediately start doing what humans do best, which is ripping everything apart and looking for something. Right? We're looking for life. Imagine then someone, drilling into or attempting to extract some of this rock and finding out that it's a biological being that way.
Uh-oh.
Mm-hmm. this is the thing. Well, first of all, they easily might not have seen this coming at all. So who knows if they were even aware of this. But also, what does that mean? Because humans are, intrinsically, we're motivated by looking for things. We're motivated by trying to find something on these planets. But, of course, extrinsically, we want to do as little as possible to affect the aliens upon landing there with our, attempting to sterilize the ships as much as we can and such. So what happens? What do we do when we want to look for something but don't know what we're looking for and can't do what humans do best, which is tear everything apart until we know it?
That is a dilemma, yes. I mean, in quantum mechanics, I'm sure you've heard, it's not even possible to look at something without altering it. You can't you can't detect the presence of an electron without bouncing something else off of the electron, which moves the electron. Right. This is an interesting thought. I haven't really gone in that direction in my thinking yet. So, but coming back to the so because what you said was that if you had a slow-thinking alien civilization to whom 1,000 years just isn't that big a deal, wouldn't that just be the same as it would be to us if the civilization is just closer?
Yes, but the closeness, the distance is a single, right? It's a single thing, right? So it means that we can easily communicate with a lot of civilizations who are very close to us. It cannot really be changed. The lifespan thing, it makes, instead of, making the single civilization we're talking about closer, it makes everything closer, right? It relatively changes the scale of the entire universe.
No, it doesn't. Because for two-way communications, you need the other civilization. There's always two ends to every channel of communication. So even if, even if you can broadcast further or receive signals from further away, if you are the slowest thinking civilization in the universe, that doesn't help you.
If there are several comparably slow civilizations.
See, now we're tacking more and more ifs onto this.
Well, the idea, though, is that if there are other relatively comparable civilizations to us that exist in the universe, it's much harder for us to find them than it would be for a slow situation to find a relatively comparable slow civilization.
Yeah, okay, but that doesn't help us then, does it?
It doesn't, but it does bring up the idea that there very well could be a bunch of slow-thinking civilizations speaking over our heads that we don't even know about.
Yeah, because they're too alien and we don't recognize their signals. That's right.
I guess it's much more likely that that's the case than there are a bunch of fast civilizations above us.
Well, I think what's much more likely is that civilizations will tend towards approximately the same kind of speed. That there's no real reason to believe that we are, that we're somehow magically endowed or magically, more efficient, or that our evolution has somehow come up with some sort of breakthrough that, the evolution on other planets wouldn't. There's also no reason to believe that their evolution would somehow stop at somewhere when it could still be improved.
But does thinking faster mean being improved?
Oh, absolutely. 100%. I mean, just think about how different the world would be for you if everything around you were slowed down by a factor of 10, but your thinking is still the same, right? That's the same as your thinking being sped up by a factor of 10, right? So, even though, everything's still the same, you would have to get used to controlling your body at that speed, but once you've done that, you would be effectively much more intelligent because now you can put a lot more thought into everything you do, into everything you say. In a conversation, you would have much more time to think about, what kind of meanings could have been intended by the other person. You can go through several mental drafts of what you're going to respond, how it could be taken by each of the people present in the conversation. You would effectively be much more intelligent, even though your thinking hasn't changed. It's just faster.
That's interesting, but I feel like there would also be pros to being a slower thinking being as well that easily could have developed independently from the track that we're on.
Name one.
You live longer and can experience more.
No, you can't. Not if your thinking process is slower by the same factor.
That's fair. You experience longer stretches between events rather than the scale that you experience is more spread out.
Yeah, but what kind of events are you looking for? I mean, are you looking for cosmic events? Those tend to take millions or billions of years to happen. And if you're thinking about events in their civilization, well, then those will be slowed down too. So no, I don't think that would. So the number that you're looking for is the lifespan divided by the speed of thinking, right? Or differently put, how long you can live while still having the same speed of thinking.
Mm-hmm. Well, something that like I guess my brain is stuck on is why don't we think faster? Is it a physical limitation of evolution that we stopped thinking at this we stopped thinking faster at this speed? Or like does intelligence require us to think at least this fast? I feel like we just developed at a number that was, at a speed that was it's just the way that it happened. It happened randomly by process by natural selection. It did not happen by design. So easily that could have been faster or slower if it were done independently elsewhere.
That is true. I can answer that question. Why don't we think faster? Because there are actually two separate answers to this. One of them is that the specific way that our brain has evolved, it works by chemical diffusion. So, in terms of comparing it to electronic circuits, that's just super slow. But then the question obviously becomes, why doesn't evolution evolve our brains away from that and into something more effective or efficient? Well, the answer to that is simply that it can't, because there are some changes that cannot be done gradually. My favorite example of that is the human eye. Are you aware of the predicament of the retina?
I am not.
Okay. Are you aware that we have a blind spot in our eye?
Yes.
Right. Have you ever wondered why we have a blind spot in our eye?
That's a good point. No.
Right. See, a lot of people rush to the answer, well, yeah, that's where the optic nerve connects to the retina to the brain, right? So that's where the blind spot is. But that doesn't really answer the question, because why couldn't the optical nerve just be behind the retina? Why would it have to have a blind spot on the retina?
Mm-hmm.
Right. So the full answer to this is that the information that is received by the retina, so the light that falls onto the retina, is processed by a layer of nerves before it is being sent to the brain. So the information that is sent to the brain is not a pixel by pixel image, but rather, it's information about like colors and shapes and edges and angles. It's some pre-processed data. And the really crazy thing is that this layer of nerves that does this processing is in front of the retina. All of the light that falls onto your retina has to go through those nerves before it can reach the retina.
Okay.
Right. Now, if any intelligent designer created this, they are super stupid. Right? That's the dumbest design that you can make, because you're just blocking a lot of the light that you need in order to see, and then you have to have a blind spot because you have to send the information through the retina into the brain.
Mm-hmm.
But why doesn't evolution just fix that? Well, because you cannot fix this gradually, right? You cannot move that layer of neurons through the retina in small steps. It would have to be a drastic sort of stepwise change, right? And evolution just simply cannot do that. So the same is probably true of the specific design of neurons which make up the brain. Our intelligence is a function not so much of the neuron itself, but the interconnection between neurons. Right? And if any small detail on how the neuron actually works were changed, then intelligence itself just breaks down.
Mm-hmm.
Therefore, again, evolution by natural selection cannot do that.
Okay.
So that's my long answer to the question, why is our thinking process so slow compared to electronics? Well, because evolution just kind of got stuck in this blind alley of sorts.
As opposed to and like I guess is just a matter of luck which one was hit first, which speed of thinking developed first, and that one took off. And there was no going back to correct it.
Yes, that is true, but at the same time, you also have to remember that whatever does evolve has to have evolved through gradual changes. Okay, so that if the fastest way of thinking is in fact an electronic circuit, but it is not possible to grow an electronic circuit through natural selection, then that will never happen.
Oh, well, yes, of course.
So it's still possible that our brain, despite being much, much slower than a computer, is still the fastest that biological evolution could do. But we don't know if that is the case, but it could be. By the way, just regarding the thing with the retina in the eye,
Yes.
there have been at least two separate paths of evolution that have evolved optics, right?
Yes.
Most land animals have this sort of retinal problem. Even insects, which have very different sort of shapes of eyes and different sort of optical principle, but they still have that problem. But the other independent evolution of an optical organ happened in marine animals, most notably the octopus. The octopus has eyes in which the retina is properly in front, the nerves are behind it, and there is no such blind spot. So evolution can create the correct thing, and it just happened in our case that it didn't, and now it can't fix it.
So this is super interesting. So first, this proves that once something sort of gets done by an evolutionary process, there's not much going back. Right? After you build this change, and as that becomes the dominant version of that species that then goes on to reproduce, there's no going back and trying again.
Not in that species, no. Unless, of course, the trait that evolved somehow, well, I mean, one way of going back is to just lose that trait and then just, evolve it independently again. But in the case of evolution and also the case of vision, seeing, sorry, did I say evolution? I meant intelligence. In the case of intelligence and in the case of eyes, that cannot possibly happen because losing that trait would lose your survival advantage.
Okay, let's rephrase that then. You don't get the chance to redevelop beneficial traits. If it's at all beneficial, you don't get the chance to redevelop it because it's going to stick. You can only iterate upon it.
Actually, no. I mean, we could, in theory, develop a new pair of eyes on the back of our heads, and retain the ones on the front, and because now we have, additional ability to see behind us, which is also a survival advantage. And if that second pair of eyes then evolved the right way, then that could totally work. But then again, there is this trade-off because growing this extra pair of eyes on the back requires additional resources, to grow it, to maintain it, and to process the signals in the brain, etc., etc. And all of those are costs that evolution has to weigh against the benefit.
Mm-hmm.
Right? So those costs might not be worth it, which might also apply to faster thinking processes. Maybe having a thinking process too fast requires such a high metabolic rate, and therefore a higher rate of energy intake, that it's just not feasible in the kind of environment where we evolved. I mean, I don't know if you realize this, but smaller animals like flies do have a vastly faster thinking process than we do. Right? They're just not our level of intelligence, but they are much, much faster than us, which is why they can easily dodge, your hand or your fly swatter.
Yes.
Most of the time.
I was going to bring this up, but I wasn't sure if I was correct, so I just didn't.
Oh, I'm sure it is correct. If you could experience what it's like to be a fly for just a moment, someone told you you're gonna experience being a fly for 1 minute, right? And then after 1 minute you're back in your human form. You would feel like you've just spent, much more than a minute, like maybe an hour, whatever. I don't know what the exact speed factor is, but
yeah.
So to the fly, your hand and your fly swatter moves much, much slower than it does to you.
Yeah, no, I was just saying I didn't know this for sure. So You knowing it for sure, I trust. I just, didn't have a source to back it up. So you could have easily known more than me. I was less sure of myself. Anyway, that makes it interesting, though. This sort of entire line of reasoning, doesn't it kind of shoot the idea of intelligent life trending towards a certain speed of thinking in the foot? Like, you can't really have that idea while also recognizing this entire conversation so far about speed of thinking.
I'm sorry, you lost me there.
You had said, you had proposed idea earlier that intelligent life tends towards a certain speed of thought.
I see what you mean. No, what I was getting at there is that if a specific design of neurons is efficient enough, then evolution will optimize it as far as it can, without fundamentally changing the design of a neuron, which it can't.
Mm-hmm.
Right? So evolution is not going to make you think slower than it could make you, because it's always a survival advantage to think faster if the associated cost is low.
Now, so the idea is then that what if, evolution just develops a very slow-moving neuron first that cannot be optimized to the degree that ours can?
Right. Then there are two possibilities. Either you end up with a very slow-thinking species, which could happen, or a faster-thinking process develops independently and just, outcompetes them.
There's no known species that has two separate, completely independent thinking processes, I imagine.
How do you define separate and independent?
I don't know, because you're the one who said, they can independently develop a different thinking process.
Oh, right, because I was saying about developing a separate set of eyes.
So if you developed a separate thinking process, what would that mean? I feel like we would immediately attempt to classify those as two different organisms that are now working together.
When you talked about two independent thinking processes, my thought immediately jumped to the fact that we have two brain hemispheres, and that is possible to separate those two brain hemispheres and get a person that has two separate thinking machines in it, each of which think of themselves as a person. That should go into our episode on the person as a unit of agency.
Yes, definitely.
Definitely. Without dwelling too much on it, I just want to point out that dolphins, because they are mammals, they also have two brain hemispheres, but because they're marine animals, they live in the water, but they need air to breathe, so they have to periodically get to the surface.
Mm-hmm.
Therefore, they cannot sleep with their entire brain at the same time because they would drown. So what they do is one brain hemisphere sleeps at any one time while the other one stays awake.
That's really amazing.
Yep, and I have no idea what that would feel like. I'm super curious to know what that feels like, but I guess I'll never know because humans don't work that way.
That's so weird. Anecdote time. Have you ever had to take like a micro nap, or like had a situation where it was good for you to still be aware of your surroundings while also sleeping?
I have heard of people who do that, or who are capable of doing that, but I don't think I've ever done that. I don't think I'm capable of it. I cannot even imagine what that would be like.
I developed being able to do it in school because I would sleep a lot in class, but there were classes in which case I would have to sleep, but also be able to participate in discussions whenever I was, called upon or whatnot, versus classes where teachers would let me sleep. So I developed this sort of like ability to sleep, and in the sort of the same state that you sort of feel dreams in. Like imagine a dream, but that dream is basically exactly what is going on around you. Right, so I have this groggy sort of idea of the state of things going on around me while I still feel asleep, and then can snap out of that to interact if necessary.
Okay, I think I have experienced that, but not to that extent. I mean, if it does happen, then only randomly and by accident. I couldn't possibly plan for it,
Mm-hmm.
and and I don't think I would be aware enough of my surroundings to be able to, to recognize when I'm called on by the teacher.
Yeah, ending anecdote, but I had to be able to not only recognize when I was called on, but also have an understanding of what was going on, so I could say something that was relevant.
Yeah.
It
Well,
was interesting.
I guess I just did all of my sleeping before going to school,
It's probably the much
which often meant coming in late.
funny.
Right.
So,
So,
to sort of
go ahead.
backpedal to the main concept again, I don't know if this is actually the case, but is there a chance that the two hemispheres of our brain were developed, the thinking processes for each were developed separately?
No.
Okay.
Well, I can tell you about not metabolic. I can tell you about genetic signaling pathways, but I think that would go a little far.
Fair enough. Then in that case, just think of that as an interesting hypothetical to think of two different thinking organs that were developed separately, but that work together.
Right. Well, suffice it to say, I can say this much, that any part of your genes that encode for neurons or for the structure of the brain, there isn't a part of your genome that encodes the left hemisphere and then a separate part of your genome that independently encodes the right hemisphere. It's not like that. Right? So imagine a computer program which is supposed to grow a brain on it. It's supposed to generate some graphics, which is kind of symmetrical, right? So you have a left half and a right half, and they're like almost the same, right? It's much more efficient to write the code once and then just mirror the result, instead of writing two separate programs that do almost the same thing.
That's interesting. That makes sense.
Turns out that's what our genes actually do.
That makes sense, but then it makes me wonder how the two brain hemispheres think differently.
Again, I would love to go into that, but maybe we should.
Yeah.
So the next item on the list regarding the Fermi paradox, and by the way, I love that we're going through this list slowly and we keep finding tangents to go on. That's brilliant. That's awesome. The next item on the list is that we are not listening properly. Hang on, wait, I think we've already mentioned that. It essentially says that we don't know what aliens are going to be like, so we don't really know what to listen to. Okay, there is another one that says maybe civilizations tend to stop broadcasting detectable signals pretty quickly. And in fact, there is precedent for that, because how much do you know about analog and digital television?
A little.
A little? So you know that when we had analog television, anyone could just, take a television set, pick up the sort of, the broadcast waves that are just swirling through the air, and see the picture, right?
Mm-hmm.
And now that we have digital TV, you can still do that, but only because your television set now has a complicated circuit in it that can decode the digital information that is encoded in the broadcast. Right? So what I'm saying is that the analog signal is so simple and so primitive that, an unsuspecting receiver can easily recognize it as a signal that has information. But digital television is encoded, it is compressed, it requires knowledge of the specific format, the specific compression algorithm in order to see the picture. And if you don't know any of these things, then just looking at the raw signal, it easily looks like white noise.
Yeah.
Right. So if an alien civilization were to broadcast detectable radio signals, such as, television or even just radio, we might be able to detect it in its earlier stages when it's still quote-unquote analog, but very quickly they will realize that they can make more efficient use of their radio bandwidth by using digital encoding and compression, and then their signals become indistinguishable from white noise.
Wouldn't they just send out the most analog, basic, primitive signals they possibly can to cast a wide net?
If they were trying to contact other civilizations, yes. But but
the idea is that maybe they're not.
Well, the idea is that the best shot we have at detecting an alien civilization is to detect them by accident rather than by them coming to us. Because for them to come to us, they would have to discover us first. And, they're in the same predicament. We've stopped using analog television. In fact, we may even eventually stop using radio signals entirely, at least, undirected radio signals, because we now have the internet, we have, undersea cables, fiber optics, that might be more efficient. And to whatever extent that we use satellites for communication, those radio beams are very highly focused towards the satellite. They're not like old school radio communications, which are omnidirectional and just sort of propagate out into space.
I can see this being an issue.
Now, here's something that I've always wondered. In all the talk about this, about detecting radio signals from aliens, it's always radio signals. This goes a little bit into this idea of aliens maybe being too alien, because maybe they've discovered some other physical process that they can use for communicating among each other on their planet, which we might not know about, and therefore might find harder to detect. In particular, I've always wondered, what about neutrinos? Neutrinos are very, very difficult for us to detect. I mean, the technology that we have to detect them is almost not able to detect them. But what if by some freak accident, an alien civilization evolves on a planet that has some kind of material in its crust, some kind of mineral or whatever, which happens to interact highly with neutrinos? And because of that, they discover neutrino communication before they discover radio waves, and therefore their entire communication technology just builds around neutrinos. And that's using neutrinos as an example, and neutrinos is at least something that we know of. What if it's something that we don't even know exists?
That does seem very strange. It feels like a very early 1980s, 1970s, 1960s sort of thought process that, of course the aliens are broadcasting radio waves. What else would they broadcast?
Well,
it seems silly looking back on it.
Actually,
but
no.
It makes sense.
Actually, no, it doesn't sound silly to scientists. Because, I mean, when we say that, radio communication is easy for us and neutrino communication is hard for us, it's not just because we happen to have discovered radio waves sooner. We do have some understanding of the physics behind it. We understand the kind of complexity of a technological device that would be required to detect neutrinos versus radio waves. And, there is a lot of reason to think that radio waves are just far, far more likely to be discovered by an alien civilization before anything else. Simply because it's the closest physical process, the closest to your sort of everyday experience. Obviously, the absolute closest to your everyday experience is sound. We've evolved to actually use sound, and so now we've we've invented technology that allows us to transmit the sound across the internet. As one of our viewers said in the chat last episode, we're transmitting zeros and ones through the internet and we turn them into sound signals in our headphones. But sound doesn't transmit through space, so the next best thing to transmit through space appears to be radio waves.
Interestingly, there are probably beings on our planet that I just don't know about, but are there beings that have evolved to detect radio waves?
That's entirely possible. Not on our planet, but
okay.
I mean, in a sense, how do you even define radio waves? Because what are radio waves? Radio waves are actually just electromagnetic radiation at a specific frequency.
And there are definitely beings that can sense electromagnetic.
Yeah, we can. We can see visible light.
Oh, well, I mean, that's true. That's
Yeah, that's what I'm saying. We have this very narrow segment of the electromagnetic spectrum that we can detect. So it's not actually that big a stretch to imagine that an alien civilization could evolve to detect any other chunk of the spectrum. And they might potentially use a chunk of the spectrum that we call radio waves.
This is interesting. Everything is so interesting. Then, do you think it's possible that there are, a creature develops and evolves to not interact with the electromagnetic spectrum at all, and instead interacts primarily with something else?
Okay, need to be careful there with our definition of interact. Um,
Like I guess senses.
right.
You
Okay.
know.
There are certainly species that do not sense light at all, but I mean, I'm thinking of species that live in environments where light just simply doesn't really occur. You know, like in the deep sea or inside some volcano. You know, some sort of extreme conditions. We have found weird life forms on Earth in all sorts of extreme conditions. There's bound to be something somewhere that doesn't have any light sensors at all. However, I expect that to be rare and only occur in those circumstances where light really doesn't get. Because as soon as detecting light confers any kind of survival advantage, then it's just gonna evolve.
Hmm.
I mean, it doesn't have to be a fully fledged eye. You know, I mean, the eye as we know it also evolved from primitive beginnings, right? But all you need to start off with is a cell that has some kind of molecule in it, some protein or something, that undergoes some kind of chemical reaction under specific light influence. And there you go, you have something that detects light.
I'm currently sort of thinking now about the different avenues of senses. You know, electromagnetic being one of them, vibration being another one. Thinking about others that could travel through space aside from electromagnetic or vibration just can't.
Interesting you say vibration, because vibration, we have two different ways of sensing vibrations. We
Yeah,
can sense sound, and we can
and
sense
touch.
very low, yeah, very low frequency vibration. We can tactile, I guess is the term
Hmm.
technically. Um,
Yeah, no. But so then, are there other things that can be sensed like this, and should we be sending out signals like that?
well, as I said, it seems that scientists have thought about this a lot, and it seems that radio communication really is the most. I don't really know what the criteria are, but the amount of resources that you need to put into such a technology, must be the
Hmm.
same for alien civilizations. So that's a kind of non-culturally biased measure. The complexity of discovering a technology that can detect it is also a kind of universal measure. You know, and if both of these are relatively low for radio communication, then radio communications is just gonna win. I mean, if you look at some of the experiments that we have built to detect neutrinos, they're ridiculous, both in terms of cost and in terms of technological complexity.
Again, might that be a aliens are just too alien for us to understand thing, or
I try to avoid that by trying to apply measures that should apply universally.
I know, but it doesn't. I don't know. It didn't seem to convince me at least. But I don't know why.
I did kind of qualify my statement there by kind of deferring to scientists because I don't know quantum mechanics that well, but since all of this talk among scientists, among astronomers, among astrophysicists seems to concentrate so much on radio waves, that tells my Bayesian reasoning that it's far more likely that they've thought about this and that there is some sort of conclusion that they drew, rather than they're just stuck in some kind of bias and I am the creative snowflake that is able to think out of the box.
Well, personally, I can think of a reason, for instance, why they would do this, despite the fact that it might not be the best way to do it, which is it's cheap to send out. It's much cheaper to send out radio waves than anything else for us
Yeah, but then why would it be cheaper for us but not for the aliens? That's the point.
because we live on a planet that has a whole bunch of organisms that can sense electromagnetic radiation. So it makes sense for us to develop this as a thing.
Well, you say that, but actually I don't think at the time that we invented radio, um, radio waves, radio communication, I don't think that we knew at that point that it is in fact the same physical phenomenon as visible light.
That's very fair. I actually know nothing about the creation of radios. So,
Yeah. So I very much doubt that we knew at the time that visible light is genuinely the same phenomenon. And it's much more likely that we discovered radio waves by some freak experiment that just had some unintended effect, and then someone dug deeper, and then they managed to create some kind of circuit or some kind of antenna or something, which happened to have some effect on some other part of the apparatus somewhere else, and ta-da, you have a form of communication.
I am interested in looking into this later. Are there more things on the list?
Yeah, definitely. The next one is that aliens might, or that sorry, that technological civilizations in general might tend towards putting themselves into virtual environments. Because one thing that intelligence can do is to pick a goal and then pursue it, right?
Mm-hmm.
And what is our goal? Well, it's kind of to be happy, right? And one way to be happy is to entertain ourselves, right? So
Yes.
a lot of effort in like even within a specific field, like let's say computer technology, a lot of advancement goes into improving games, right? We have
Mm-hmm.
GPUs, we have graphic cards, we have
Virtual reality.
virtual reality. Well, I was gonna say we also seem to optimize our internet speeds in such a way that multiplayer, to reduce ping and stuff like that. There's a huge demand for every kind of technology that improves our gaming experience. There's much less interest in improving our technology to, I don't know, to make it more fun to do mathematics. I mean, we do make it easier by building computers, but it's just not something that we occupy ourselves with. It's something that we want to differ off to the machines. But the games we want to play, we want to actually spend our time playing the games, and we create the technology in the service of that goal. So the argument then goes that maybe intelligence is generally like that, in the sense that it always tries to come up with some kind of technology to keep itself busy and entertained, and everything will tend towards some kind of virtual environment in which everyone will just spend their lives, and then they just lose interest in the outer universe.
And of course, the other parallel to this is, instead of doing it in a virtual way, doing it in a chemical way, with things like heavy drug use.
Okay.
Accomplishing the same effect.
Fair enough. I didn't expect it to go that way, but instead of chemicals, one of the things that is listed as an example is mind uploading. Once you have a virtual environment in which the entire world is simulated, you might as well also simulate yourself.
Mm-hmm.
Right? So you stop existing in a biological form, and you just let the virtual environment simulate your biological form. And then at that point, the outer universe just doesn't matter anymore.
I was going to say, I feel like all of these fall under sort of the same entertainment umbrella.
Right.
We're not going to find them because they don't care about being found. They're just they're happy where they are. They've achieved the goal of be happy.
And they also won't find us because they're not looking. Yeah.
Mm-hmm. It's funny. Another slight anecdote. This is brought up in a rap song that I like, actually, which the line is, I've got my own theory. There are a million alien planets at leisure smoking alien reefer.
Interesting. Yeah, that's literally that theory, 100%.
Mm-hmm.
Right. But to be honest, I don't think that humanity is going to go that route. I mean, I did mention all this demand that exists for gaming equipment and stuff, and we do spend a lot of time on that, but not all of our time. There are heaps of people who are interested in science and scientific research and scientific advancement, the advancement of knowledge, including knowledge about the universe. And even if we did have a virtual environment in which you could potentially live your entire life and be happy, it's still not clear to me that everyone would do that. It seems to me that a population of people who are just far more interested and far more focused on the real world will just, spend their time and expend their effort on the real world.
I feel like intelligent life would actually trend away from would trend towards scientific advancement and away from just being happy, because in fairness, if society trended towards just being happy, then we probably wouldn't have tried to develop we wouldn't have developed as much cognizance of our situation as we are now, as much like understanding of outside situations. That's really unnecessary to live a more happy life. All you need to do is like early civilization where it was mostly farming. Our civilization, our society would have been halted progress wise a long time ago had that been the main goal that was driving us.
I don't agree.
Really.
I don't agree because throughout life, since the beginning of humanity up until today and still today, there is always something about the human condition that can be improved, that can increase our happiness. We still have suffering in the world. We still have injuries and diseases and viruses. We still have unfortunate events. We have accidents. We have, there are so many things that a technology could potentially address and make us happier. And
Sure.
and finding out more about the cosmos and about other planets could potentially be used in the service of that goal. So my theory is actually that the reason we have this sort of universal curiosity, we're curious about almost anything, and so we have all these sciences to cover almost anything, is because the more we know, the more effective we are at achieving our goals, no matter what the goal is. So even if the goal is being happy, then we would still do almost anything to find out as much as we can about as much as we can, and use that in the service of that goal.
Okay, fair enough.
Now we get to some of the things that I was actually meaning to talk about. And I know this is a little bit late, but I still want to go through this. There is this hypothesis called the zoo hypothesis, which I've held on to till now. Imagine that imagine we were the most intelligent civilization within our sphere of influence, and then we happen upon a planet where some intelligent life, but not quite as intelligent as us, is evolving, right? What will we do? I mean, you said that we would probably land and tear everything apart to find out as much of it as possible, but it's just as possible that we might take the very ethical approach and say, this is a natural process, we should keep it pristine and pure and not interfere. So we're going to stay away from this planet. We can, passively observe it perhaps, but we will try our best to remain undetected. Because eventually they will develop some kind of intelligence that will, allow them to detect various things. They can detect radio waves, they can deduce things about the universe, right? So it would be in our interest to say, let's try our best to remain hidden from them. And now, of course, you know where this is going. The less intelligent civilization on the planet is humanity, right? And the more intelligent civilization is an alien observer. In other words, we are the zoo. So the idea here is that the alien civilization would have some kind of cultural tenet or dogma that we're supposed to be left alone in our natural sort of evolution, and in the service of that goal, they provide us with an illusion of a universe that is devoid of life because they want to remain undetected.
Now, out of curiosity, let's spin this back to humanity doing this to another race. Don't you think that if we were able to pick them up, first of all, we definitely would have done all our best to translate their language. If we had the ability to tell that they were talking about things like this, don't you imagine we would attempt to make contact after that point?
Maybe, but maybe, but maybe not. I mean, it's difficult for us at the point that we are in our evolution right now. It's difficult to imagine encountering a civilization that is capable of language and capable of this sort of logical reasoning while still being significantly less intelligent than we. And I think
Really?
Yeah.
Like, go on. Go on.
Yeah,
Sorry. I was.
and I think the reason for that is that we are just at the beginning of the evolutionary scale. We have evolved language only 100,000 years ago, which is tiny on a geological scale or on a cosmic scale. Um, so we are probably the least intelligent that we can get while still having language.
I could definitely imagine an alien society that is just on the same evolutionary path that we were, just, several thousand years back.
Oh, but that. Then we're talking about different definitions of intelligence. You're talking about technological advance.
Mm.
I am talking about actual intelligence. We were not less intelligent than we are now 2,000 years ago, or even 10,000 years ago.
How would we then become more intelligent in the future?
Through transhumanism, through technological advancement, through implants in our brains, or maybe mind uploading, whatever. Lots of possible ways.
Interesting.
Okay, so let me swap it around now. And again, you're a human. You have language, you can talk, and you have sort of logical reasoning. Now, let's say there is some other species in front of you, like let's say a cat or something, or an ant, right?
Okay.
Even, okay, see, this is difficult because obviously the animal cannot talk in a way that you can understand, right? But these animals do have a form of communication that they use to communicate with other members of their species, right? In most of them, it's body language or smells, pheromones, whatever, right? So let me fast track this because I don't know how to get into this. We don't seek the dialogue with them. Why? Because they just have nothing interesting to say. Anything that they could possibly tell us, we already know because we're significantly more intelligent than they.
I don't know if we don't seek dialogue with them. I feel like some people sort of do.
But maybe with cats and dogs, but only just about. But an ant?
That's fair.
Right. So when humans want to, like, let's say, build a highway or something, right? You don't negotiate with all the ant colonies that are in the way. Right? We don't seek the dialogue with them. We don't respect them for their unique views. Right? We kill them with impunity. And why do we do that? Well, because we don't think that they have a valuable contribution to make to our technological advancement.
I don't think that's true. I think we kill them because they're common.
Right, okay, that goes hand in hand with the other one.
I don't think so, because humans might not be...
I do think so, because if you had 7 billion humans and 7 billion humans on one side and 7 billion ants on the other side, right, the total information content of the 7 billion humans far exceeds the information content of the 7 billion ants, because those 7 billion ants are all pretty much the same, right? If you took the entirety of the knowledge of those 7 billion ants, that amount of knowledge would probably fit into a single human brain.
Okay, I didn't realize that was what you were talking about again. Okay, I had a different context.
Right. So when you say ants are common, you don't just mean ants as a whole. You don't just mean we can find any ant somewhere else. What you actually mean is we can find an ant that is extremely similar to the same ant. Extremely similar in all respects that matter to us as humans. Right? So the information content in that other ant is not significantly different or unique or valuable compared to whatever other ant. It's very different for humans, right? If we kill a human, then we've lost something that we can't replace even with another human.
I guess I'm already thinking of a step up, whereas if an alien kills a human, they would maybe find that a difficult thing, not as simple as the ants, because even if they don't understand us and think we have low information content, there's very low amounts of life in the universe like that, or at least that we can detect. So if
Again-
we found an alien, we would be worried.
Again, I have to disagree. I mean, in your premise, you're now saying that they don't understand us and just assume that we have low information content. But I am saying that they probably know, because they do understand us. And we understand ants, right? We know everything about ants. Killing an ant doesn't destroy anything that we don't know.
But like killing an endangered animal doesn't destroy anything we don't know, but it's still frowned upon because they're endangered.
Right. Okay. That's a separate issue. But what I'm getting at is that if our level of intelligence is to the aliens as the level of intelligence of an ant is to us, then the aliens are likely to treat us the same way that we treat ants.
I would only agree with you if there was, if the population matched the same sort of ratio of humans to ants, right? Ants outnumber humans massively, so it's easy to just kill a bunch of them and not care. But something that doesn't have a population that, outmatches humans, those are much harder to reason to kill, and there are huge groups of people attempting to stop it.
I know what you mean, and I
Out
agree
of
with that.
preservation.
I agree with that to some extent, but still, if we're building a highway and there's an anthill in the way, we don't actually stop to make sure that that particular anthill isn't the last one of its species. If it were known that it is the last one of its species, then some animal rights activists, no, not even animal rights activists, but some preservation activists, might cordon off the area or something to prevent something like this. But the point is, we don't do it preemptively. If the anthill is in the way, then it'll be gone.
I guess, but like we still do things with like protecting environments like rainforests and whatnot.
Right.
Out of preservation, even though they would be highly beneficial for us.
Right. Hence the zoo hypothesis. Right. The zoo hypothesis doesn't say that they'll just come in and destroy Earth, but they would just come in and say, okay, we're just going to leave them in the natural evolution, and just see where they go, and mostly not care about them, but still go for some amount of length to ensure that we remain undetected.
Mm-hmm.
Which is more than what we do with ants. I guess we just assume that ants don't really detect us at all. Actually, I read this on Reddit the other day. It was a question which I found really interesting, which is, why do insects like wasps and bees, why don't they show obvious signs of fear when they encounter a human, which is much bigger and much more threatening, much more dangerous to them? Why don't they immediately fly away from it? Right? And the possible answer may be, one of the speculative answers posted, is that we are just so big compared to them that they don't actually recognize us as a thing.
They just recognize us as part of the landscape.
They recognize either as part of the landscape, or or they just simply have no concept of what we even are. Because their brains are just so simple, and their information processing just can't go that far. It can't go as far as to say that, well, that person might have an intention to kill me if I annoy them. That just might not even be within their range of thinking. So an advanced alien civilization might be kind of similar to us. Maybe they are somewhere in our solar system observing us from afar, and we can't really detect them because we don't even understand what it is they want or what they are.
Personally, I don't know. This is one of the points where I don't have a lot to say on it, because it's sort of like, if it's true, nothing changes. Except for now, we know that we're spending a ton of effort on something that would never change ever, which is unfortunate. This sort of idea, I think out of hope that knowing that we were talking about trying to meet an alien civilization would make them go, perhaps it's best to do this. If not, I feel like it's more out of malice that they would keep us hidden or keep themselves hidden than the other way around. Like, it wouldn't be out of protection to us.
Well,
Though, in fairness, I did suggest exactly the same thing when we were talking earlier about the chimp with expanded intelligence. I did literally propose the exact same thing.
yes, and you're not alone. I was going to bring Star Trek into this because Star Trek has this concept of the so-called Prime Directive, which is a sort of directive that several advanced civilizations in the Star Trek universe follow, which is that an underdeveloped civilization, and they have a sort of arbitrary cutoff line where they consider a civilization to be advanced enough, that any civilization that is below that line simply must not be contacted and must not be allowed to detect the existence of other life, because they're supposed to be kept in their own evolution or development. They're not supposed to be influenced by the thoughts and the technology of advanced civilization until they're quote unquote ready. Right. So, a lot of philosophy has been written about this so-called Prime Directive. And in fact, Star Trek itself has explored the Prime Directive in many ways. There are many situations in which the Prime Directive leads to a course of action that seems on the surface unethical. Like, for example, if you have a planet that is ravaged with environmental effects, like volcanic eruptions or something, should you interfere to prevent loss of life, even if that interference means that you will be detected, which would go against the Prime Directive, right? It is said repeatedly in Star Trek that the Prime Directive, by default, means that you should let them die. So yeah, it's after however many years of Star Trek, this is still an open question whether you should actually interfere if it means that that you would necessarily make a first contact with a civilization that is far below your level of technological advancement.
I don't have enough reasoning for this, but I assume, like, from just the sound of it, it sounds like the Prime Directive is pointless. It sounds like it just makes much more sense to initiate contact. Always.
Well, the reasoning for the Prime Directive, of course, is that every time that a more advanced civilization has contacted a less advanced civilization on Earth, in the history of Earth, it has usually been disastrous for the less advanced civilization.
Yes, but that's usually because the more advanced civilization comes with malice. That does not have to be the case. And obviously, if they're thinking about the Prime Directive, then they don't want to bring malice. So it already... Maybe this is an example of learning the wrong lesson from history.
No, I think I have to disagree with this. Unfortunately, I don't know much about this, but I'm pretty sure that there are lots and lots of examples, or at least enough examples, where no malice was involved. There was no ill intent, and yet the less advanced civilization still massively suffered due to the unintended consequences of suddenly introducing, a jump in cultural and technological advancement.
I cannot think throughout my entire knowledge of history at a point where this was the case. The closest thing I can think of was introducing diseases from the New World to the Old World, and again, I don't think that was, from the Old World to the New World, and again, I don't think that's fair, because diseases were also introduced the other way around as well. There were just fewer in the New World than there were in the Old World. So that was just a luck scenario, not necessarily... They didn't have fewer diseases because they were less advanced.
Well, I'm sure our viewers are going to tell us all the ways in which we're wrong and all of the things that we're missing from history. If you have any such ideas, please get in contact with us. You can email your questions, comments, concerns, or suggestions to thekeeptalkingpodcast@gmail.com. And of course, you can leave comments on the YouTube posting as well. So we are now at the 2 hour and 6 minute mark. So let me take a very quick look at the kinds of comments that we've received about our previous episode, in which we were talking about truth and objective truth, perceived truth, and faith and belief. One of our viewers by the name of Numdegaset, or Numdegazed, I don't know how to pronounce this, said, an example of objective truth is the example that Mount Everest still existed before it was discovered. Before then, the consistent and perceived truth was that there was no such thing as Mount Everest. However, that mountain still existed and was objectively there. This is, in fact, something that we hadn't covered. Objectively true is that which doesn't go away when you stop believing in it.
Mm-hmm.
Right? So we kept talking about, the kinds of things that you can make yourself believe, like that the Earth is flat or whatever. But even if every person on the planet believed that the Earth was flat, the Earth would still be round. And all of the observations that we make would still be in accordance with it being round, even if everyone denies that evidence.
So the idea here is that it makes the false belief that the planet is flat an inconsistent belief, whereas there is a very real chance that you could have a consistent belief that Mount Everest doesn't exist purely by never having any contact with any, purely just out of not knowing about Mount Everest. So it is possible to have consistent beliefs that are also wrong, right? Beliefs that are purely consistent with the facts just implying that you don't know enough.
Right, but I think the point here is because I mentioned the example of the heliocentric versus the geocentric model of the solar system, and oh yes, that's right. I mentioned in the last episode that there was this this quote that I quoted. How would the universe have to have looked different to look as if the sun was in the center rather than the Earth in the center, which is what it does look like? Our universe could be totally in accordance. All of our observations could be totally in accordance with some kind of hypothesis that seems obvious to us. The hypothesis that the Earth is in the center, until we stumble upon some kind of more subtle or more advanced evidence. And that new evidence doesn't change the truth. It only changes our perception. It's not like the sun is suddenly in the center of the solar system. It has always been in the center. We just didn't know.
It takes what was previously the consistent truth and modifies it so that there is now something that makes it inconsistent and requires you to adapt to a new consistent truth.
Yeah, exactly. And that more consistent truth could, in some sense, be seen as more true.
Mm-hmm. I think this is just sort of highlighting and better defining the terms that we were using there, being, consistent truth versus objective truth.
Okay, one viewer by the name of Blananas2 is mentioning that not only not only opinion and fact could be on a sliding scale, but also truth and falsehood. For example, the example that he gives is that a dog is definitely alive. That's a definite truth. A rock is definitely not alive. That's a definite false. But Schrödinger's cat, is it alive or false? Is it true or false? There might be more than one right answer.
I dislike this sort of idea. Personally, I think that an objective truth in all cases exists, an objective truth, whether or not we can measure it or tell it, right? Whether or not we can show that it is consistent with our beliefs, whether or not we can prove that the truth is consistent or inconsistent, it still exists. I don't think that there are wishy-washy definitions of truth. I don't think there's a wishy-washy answer for any objective truth.
I would agree, yes. If we are unsure about the answer to a question, then we just have more to find out, but there is an underlying truth.
This, of course, also, it should be said, there's no proof for this.
Indeed.
This is very much the wait and see argument, which I hate invoking, but it is something I choose to believe, for better or for worse.
Well, if this was our main topic today, I would go into the Gödel incompleteness theorem at this point, but unfortunately we've run out of time. So we're gonna have to put an end here. And but of course the conversation never ends. We're just going to keep talking. So we hope that you're going to join us again next episode, episode 4, on the 21st of July. What is our next episode's topic?
It was, I believe, we're doing knowledge versus understanding, talking about the cultural repercussions of those two different, prioritizing either of those modes of thinking, as well as the benefits and detriments to prioritizing either of them.
Perfect. That gives us something to look forward to. So hopefully next week we'll see you all again. Thank you for joining us. Again, if you have any comments, questions, concerns, or suggestions, email us at thekeeptalkingpodcast@gmail.com or leave a comment in the YouTube section. If you like what we do, please visit our Patreon at patreon.com/keeptalking. We're looking forward to seeing you again next week, and until then, it is goodbye from me.
And goodbye from me. Thank you very much for watching.
Goodbye.